Applications to education. Understanding how children think and learn has proven useful for improving education. One example comes from the area of reading. Cognitive developmental research has shown that phonemic awareness, that is, awareness of the component sounds within words, is a crucial skill in learning to read. To measure awareness of the component sounds within words, researchers ask children to decide whether two words rhyme, to decide whether the word starts with the same sound, to identify the component sounds within words, and to indicate what would be left if a sound were removed from a word. Kindergarten's performance on these tasks is the strongest predictor of reading achievement in 3rd and 4th grade, even stronger than IQ or social class background. Moreover, teaching these skills to randomly chosen 4- and 5-year-olds result in their being better readers later. Another educational application of cognitive developmental research involves the area of mathematics. Even before they enter kindergarten, the mathematical knowledge of children from low-income backgrounds lags far behind that of children from more affluent backgrounds. Romani and Siegler hypothesized that this difference is due to the children in middle and upper income families engaging more frequently in numerical activities. For example, playing numerical board games such as Chutes and Ladders. Chutes and Ladders is a game with a number in each square. Children start at number 1 and spin a spinner or throw a dice to determine how far to move their token. Playing this game seemed likely to teach children about numbers because in it, large numbers are associated with greater value on a variety of dimensions. In particular, the higher the number that a child's token reaches, the greater distance the token will have traveled from the starting point, the greater number of physical movements the child will have made in moving the token from one square to another. The greater the number of words the child will have said and heard, and the more time will have passed since the beginning of the game. These spatial, verbal, and time-based cues provide a broad-based, multisensory foundation for knowledge of numerical magnitudes, a type of knowledge that is closely related to mathematical achievement test scores. Playing this numerical board game for roughly 1 hour, distributed over a 2-week period, improved low-income children's knowledge of numerical magnitudes, ability to read printed numbers, and skill at learning novel arithmetic problems. The gains lasted for months after the game-playing experience. An advantage of this type of educational intervention is that it has minimal, if any, costs. A parent could just draw a game on a piece of paper. Understanding of cognitive development is advancing on many different fronts. One exciting area is linking changes in brain activity to changes in children's thinking. Although many people believe that brain maturation is something that occurs before birth, the brain actually continues to change in large ways for many years thereafter. For example, a part of the brain called the prefrontal cortex, which is located at the front of the brain and is especially involved with planning and flexible problem solving, continues to develop through adolescence. Such new research domains, as well as enduring issues such as nature and nurture, continuity and discontinuity, and how to apply cognitive developmental research to education, ensure that cognitive development will continue to be an exciting area of research in the coming years. Research into cognitive development has shown us that minds don't just form according to a uniform blueprint or innate intellect, but through a combination of influencing factors. For instance, if we want our kids to have a strong grasp of language, we could concentrate on phonemic awareness early on. If we want them to be good at math and science, we could engage them in numerical games and activities early on. Perhaps most importantly, we no longer think of brains as empty vessels waiting to be filled up with knowledge, but as adaptable organs that develop all the way through early adulthood. Cognitive Development in Childhood by Robert Siegler is licensed under a Creative Commons Attribution, Non-Commercial, Share-alike 4.0 International License.